Hey everybody. Yesterday we took a look at more things with circles, arcs, and chords. We know how to write an equation in standard form. We know how to put it in standard form for a circle if it's not given to us. Today we're going to take a look at inscribed angles inside of a circle. So off we go. An inscribed angle means the vertex of angle C is on circle O. So inscribed, think inside of the circle. So this angle is inside of the circle. Angle ACB. And most of the time we name it by the vertex, the center vertex. So angle C is on the circle. And it's an inscribed angle. The sides of angle C are chords of the circle. AC is a chord, BC is a chord. So the two sides that form angle C, which is an inscribed angle, are chords of the circle. Angle C is an inscribed angle, as I've said a few times already. It's inside of the circle. It's an inscribed angle. Arc AB is the intercepted arc of angle C. So this arc that's up here, AB, let me add a little color to it, AB. Okay, we say that AB is the intercepted arc. So you have an inscribed angle, and then as you branch out into the circle, that part of the circle that the chords make, that's called an intercepted arc. So a theorem that's formed based off of that, it says that the measure of an inscribed angle is half the measure of its intercepted arc. So we're going to be using this quite a bit today. So the measure of an inscribed angle is half the measure of its intercepted arc. So over here, the measure of angle B, which is this angle right here, it's an intercepted arc. It's an inscribed angle, and this is the intercepted arc. So the measure of angle B is half of this arc. So if this arc is 200, then angle B is 100. If this arc is 500, then angle B is 250. So whatever your measure of your arc is, take half of that, and that'll give you the angle measure of your inscribed angle. You also can go vice versa. So if they give you the inside angle, multiply it by 2 to find the arc. So they work hand in hand with each other. All right, so let's go through, and I got some circles here. We're going to go through and just see the different kind of ways that we can have an inscribed circle. So I got 3 circles here, 1, 2, and 3. So this first circle here, I have an inscribed angle, but notice that the center is on the side of the angle. So I'm going to write in red. The center is on a side of the angle. So that's one way that you can see an inscribed angle. So the inscribed angle can actually fall on the center of the circle, and you can have a side that's on the center of the circle. Next, say I'm looking at number 2. Notice I can say the center of the circle is inside of the angle. So the center is inside the angle. So if number 2 is inside the angle, then we definitely would say for number 3, the center is on the outside of the angle. The center is on the outside. And then my alarm is going off, but we'll keep right on going. So the center is on the outside of the angle. So these are the 3 cases that you can have if you have an inscribed angle. The center can be on the side of the circle. The center can be on the side of the angle. The center can be inside the angle, or the center can be on the outside. So these are the only 3 cases that you'll have for an inscribed angle. So inscribed, hopefully that makes sense to you. Inscribed angle is inside of the circle. Now we're going to go through it in this formula here. We're going to go through and use this to solve a couple of problems. So we're going to be finding the arc measure and the measure of the inscribed angle. So we're going to be using the fact that the inscribed angle is equal to half of the arc. So the measure of the inscribed angle is equal to half of the arc. So here's example 1. All right, and we're going to find the measure of angle A, and it's actually an arc. So we're going to find the arc PT, and we're also going to find the arc on the inscribed angle B. So we're looking for the measure of A and the measure of B. So let's go through some things that we know. I know that I have an inscribed angle. So here, I'm going to color this with some red, and I'm going to color this with some red. Okay, so that is an inscribed angle. So based on the formula up there, it says that the inscribed angle is half the measure of the arc. So I know that this is 60. I don't know what this is, but my formula says that this number here is half of this number. So all I need to do is do 60 times 2, and that'll give me the measure of this arc. So this arc is 120 degrees. So again, if I slide down just a little bit to look at our formula, or maybe zoom out, the inscribed angle is equal to half of the arc. So I have an inscribed angle which was 60, and that's equal to half of this number. So you can just work backwards, just multiply by 2. So that'll give me 120 degrees. All right. And I did notice I left a degree measure off here, which is important for us to get to the next part. Now I can find the measure of the inscribed angle B. So let me use a different color this time. And let me highlight. I'm going to use blue this time. All right. So now my intercepted arc starts here, and it goes all the way around to S. So I'm starting at P, and it goes all the way around to S. So if I add these two numbers together, 120 plus 30, and I'm going to need to divide that by 2. So 120 plus 30 is 150 divided by 2. I got that B is 75 degrees. So we use the fact that the inscribed angle is equal to half of the intercepted arc. For the one in the blue, if my intercepted arc is 150 degrees, we just divided it by 2. And for the one in the red, if I knew that this was half the measure that I'm looking for, we just multiplied by 2. All right, next. Same thing, we're using that one formula that we know today. The inscribed angle is equal to half of the arc. So we're looking for X and we're looking for Y. So let's start with X. No particular reason, just going to start with X. So I like to highlight my angle so I can know what I'm focusing on. So my arc that I'm looking for is from D all the way around to F. So from D all the way around to F. So that's going to be what I'm looking for. So it says if I add these two up and divide it by 2, it'll give me the measure for X. So X is going to be 80 plus 70 and divided by 2. So I got 75. So my intercepted arc started at D and it went all the way around to F. So 80 plus 70 is the measure of my arc divided by 2, and that gives me 75. Now let me highlight what we're looking for Y. So Y I'm going to do in the blue. So starts there, and it overlaps a little bit, but that's okay. And it's going to come over this way. So this time I'm looking from E all the way over to G. So I'm starting at E and I'm going all the way over and I'm stopping at G. I do not know the measure of this right here. That is not something that I know, but I can find it. So the degrees in a circle are 360 degrees. If this is 70, this is 80, this is 90, I can add these 3 up and subtract from 360, and it'll give me the measure of arc FG. And arc FG is 120 degrees. So that was not given to us. That's something that we had to find. 70 plus 80 plus 90, added up, subtract from 360 will give me my missing arc. Now I have enough information. So my intercepted arc is 70 and 120. So 70 plus 120 divided by 2 will give me the measure of Y, and I got 95 degrees. So y is 95 degrees. So notice the only thing we used was this formula that's in the center of the page. It says that the inscribed angle is equal to half the measure of the arc. So the inscribed angle is equal to half of the measure of the intercepted arc. Last thing I want to take a look at, we have some corollaries to an inscribed angle theorem. All that means is just like a follow-up. Like we have our theorem. So the theorem is what we just went over. It says such and such. So these are like some follow-ups based off of that theorem that we just discussed on the front page. So corollaries to the inscribed angle theorem. 1. Two inscribed angles that intercept the same arc are congruent. 2. An angle inscribed in a semicircle is a right angle. 3. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So we're going to use these 3 corollaries, kind of like a follow-up, like part 2, part 3, part 4 of our theorem. So we're going to use these 3 things to verify the circles that I have drawn down below. So I'm going to try to keep the 3 of them in the view and the circle so we can go through and use what we have. So the first one, let's see what I have. I got angle 1 is inscribed in a semicircle. How do I know that that's a semicircle? Because this is the center of the circle. That's why I was trying to. That's why I put that point there. It's the center of the circle. So you cut the circle in half. You have a semicircle. So this one is actually going to be corollary number 2. An angle inscribed in a semicircle, which angle 1 is inscribed inside of the semicircle. That tells us that it is a right angle. So angle 1 is a right angle. And how do I know that? Because angle 1 is inscribed in a semicircle. So we use number 2 from up above. So this right here, I'm going to say we use number 2 from up above. An angle inscribed in a semicircle. Angle 1 is inscribed in a semicircle. So by definition, it's a right angle. Okay. All right, let's see what number 2. Let's see, my intercepted arcs. It looks like they're both going to be intercepting the same spot. So if I look at the 38 angle, it comes out right here, and then it comes out right here. If I look at angle 2, I'm going to use a different color, but it is going to overlap. Notice angle 2 is in the same spot, so I'm going to put like a blue there, and it is in the same spot over here. So by definition, this is looking like number 1. Number 1, where my finger is tapping at, it says 2 inscribed angles that intercept the same arc are congruent. So angle 2 is 38 degrees, and I know that by number 1 above. So I'm just going to say by 1 above. 2 inscribed angles, which I have. Angle 38 is an inscribed angle, and angle 2 is an inscribed angle. 2 inscribed angles that intercept the same arc. So the arc that they're intercepting is this arc over here that I'm highlighting in the red. And I will go back and show you that it's also going to be the same that I highlight in the blue. So 2 inscribed angles that intercept the same arc are congruent. So I knew that 2 was also 38 degrees. And the last one, let's see what we have going on here. I see that I have a quadrilateral. It's leading me to number 3 already because I have a 4-sided figure, a quadrilateral inscribed inside of a circle. So it lets me know that some of my angles are going to be supplementary. Supplementary means they're going to add to 180 degrees. So let's start with something that I know. I know the measure of angle 1 is 90 degrees. So measure angle 1 is 90. How do I know that? Because I have an inscribed angle inside of a semicircle. So that's number 2 from up here. So I have an angle that's inscribed in a semicircle, so that lets me know it's a right angle. So let me put in that 90 is a right angle. If 90 is a right angle, then the measure of angle 2, they're going to be supplements of each other. So the opposite angles of a quadrilateral inscribed in a circle are supplementary. And I also know that angle 3 is also 90 degrees. So I know that this is also 90 degrees. And I know those two by number 2 above, corollary number 2. So I got that 1 and 3 are both 90 degrees from number 2 above. An angle inscribed in a semicircle. So the dashed line is cutting my circle in half. So angle 1 is inscribed in a semicircle and angle 3 is inscribed in a semicircle. Very similar to the first problem that we did over here. So that'll help me find the supplements that I'm looking for. So that'll help me find the measure of angle 2 and it'll help me find the measure of angle 4. I also can use the fact that I have these here that's being intercepted by an arc. So I also can use that fact here. So regardless, we can find that the measure of angle 2 is 110 degrees. And the measure of angle 4 is 70 degrees. So just quick recap in case you didn't see that. 60 plus 80, if I add that together and divide it by 2, it'll give me the measure here. So 60 plus 80 divided by 2 will give me the measure of angle 4. That's where I got that from. So I got these two by corollary number 3. And I will write that out in case when you go back and study. I did 80 plus 60 and I divided it by 2. And then I know if I add all these up, it's got to give me 360 degrees. And I do have supplements of one another. It means they're going to add to 180 degrees, and the total altogether is going to add to 360. So these are just some follow-ups. May not come up too often, just follow-ups based off of the theorem that we had. The most important part for this lesson that you need to remember is that the measure of the inscribed angle is equal to half of the intercepted arc.